Hey everyone, today we'll be going over Leetcode number 56, which is merge intervals. This is another problem of the Blind 75 list, which is a list of problems commonly asked during coding interviews. In this problem, we are given a two-dimensional array of intervals, where each interval is an array itself, with a start value and an end time. What we want to do is, based on this start time and end time, is merge all of the intervals if they are overlapping. And after merging the overlapping intervals, we want to return an array of the non-overlapping intervals. We have here two examples which are given with the Leetcode problem. There is an intervals array in this first example, which is composed of four intervals. We have 1, 3, 2, 6, 8, 10, and 15, 18. We can see that from these first two intervals, the first interval ends at 3, while the second interval begins at 2. Therefore, these intervals overlap, and we can rewrite this interval as 1, 6. The following two intervals instead do not overlap with any other interval, and therefore remain the same. In fact, in the output at the end we have three intervals, 1, 6, 8, 10, and 15, 18. In the second example, we can see we have two intervals in our input array, 1, 4, and then 4, 5. And because these two intervals overlap, because the first one ends at time 4, while the second one begins at time 4, these can be merged to 1, 5, which is in fact our output. I have redrawn this second example to the right, using a timeline. Using this timeline will allow us to figure out our algorithm for this particular problem more easily. We can see that we have depicted interval 1 as a line which goes from time 0 to time 4, and interval 2 instead goes from time 4 to time 5. We can start from the beginning from interval 1 and move on until we find an interval, if there is one, which overlaps with it. We see that it overlaps with interval 2 because while the first one ends at time 4, the second begins at time 4. Therefore, these can be merged, and we'll have a resulting output, which will be a singular interval from 1 to 5. I have also redrawn the first example from the Leetcode problem down here, using a timeline as well. This time we have four intervals, the first one going from time 1 to time 3, the second from time 2 to time 6, the third from time 8 to time 10, and the fourth from time 15 to time 18. One thing to notice is that in this case, the array is given to us already sorted based on start time. We will notice that this becomes very important in being able to use an efficient algorithm. In fact, when using this sorted array from start time, it is basically the same as using a timeline, as we can see here. We start from the first interval, which starts at interval 1 and ends at interval 3. Therefore, the first interval ends after the second interval begins. For this reason, these two intervals can be merged. When merging these intervals, we receive a new interval, which will be 1, 6. Afterwards, we see that this merged interval of 1, 6 does not overlap with any subsequent intervals. In fact, when moving on to interval 3, we see that it starts at time 8, which is later than time 6. We then move on to the end of interval 3, which ends at time 10, and we see that this does not overlap with the fourth interval, which comes after and starts at time 14. Therefore, we can conclude that the output for this case will be a two-dimensional array containing three intervals. We have 1, 6, then we have 8 and 10, which remains the same, and finally we have 15, 18, which also remains the same. Therefore, by using this idea of depicting the intervals along a timeline and sorting them based on the start time, we'll be able to figure out an algorithm which will be able to merge these intervals in linear time, because we are only going through each interval once. However, even though we are only going through the intervals array once, because we will be sorting this array based on start time, the overall time complexity will in fact be O of n log n, because of the sort based on start time. We said we wanted to start off by sorting based on start time. And the reason why we want to do this is so that we can move along these intervals as if we were in a timeline, starting from the first interval which comes along the timeline, and check one by one if the current interval overlaps with the next interval. So what we're going to do is say intervals.sort, and because we want to sort based on start time, we're going to have to pass in a key. This key will be a lambda function, and for each interval, we will sort based on the start time. In fact, remember that the intervals themselves are arrays which have a start time and an end time. So by putting this index 0, we are sorting based on start time. Now what we want to do is prepare as a resulting array, and we will say that initially this resulting array will only have the first interval in our intervals array. Then for each interval in our intervals array, starting from the interval at index 1, because the one at index 0 was already included in our result, we're going to destructure this current interval we are looking at. So we will say start end is equal to interval. And then if the interval we have currently at the end of our resulting array ends after this current one starts, what we want to do is merge the two intervals. So we can say that the last interval in our resulting array will now end at whichever time comes after between our last interval in our result and this current end. Otherwise, what we want to do is just append the new interval to our resulting array because they do not overlap. And finally, what we could do is just return a result. Let's run this solution, and we see that it works. Once again, even though this algorithm involves going through the intervals only once because of this for loop, which shows a linear time, the overall time complexity of this algorithm is O of n log n because of the sort that we are doing based on start time. So let me just change this up here because I had a typo. I want to make sure you guys got that, but this is an n log n runtime algorithm. Thank you so much for watching this video. I hope you found it helpful. If you liked it, please subscribe to my channel, and I'll see you on the next one.